This video it's a discussion of kinematics. So kinematics is just another word for modeling motion with mathematics. That is, you're going to see some equations and even some calculus, at least derivatives, in this video. And then I'll discuss integrals of motion in a following video, as well as a bunch of examples. But at some point soon, I'm going to describe how what we're really modeling is translations in space over time. And the idea is we're not going to study rotations or spinning, anything like that. So it really is about the translation through space in time. So when somebody models motion, it's really based on some language that people sort of naturally have. And maybe the most natural word that first comes up when somebody discusses something moving is to describe how fast it's moving. So speed is a word that we have to address when we study kinematics. There's a related word that quite honestly is more interesting in physics, and that word is velocity. So I'm going to put a box around it because this is a really important word. Some other very important words are position, displacement. Let's see, another interesting word is distance. Oh, and then a big deal word, especially for Newton's laws of motion, because Newton's laws of motion that you'll learn about later is all about the acceleration. So I'm going to put another box around this one, acceleration. And then another box, really, I should draw around position. You'll see that actually I mentioned before that this video is about using some mathematics, and you're going to see some functions. In particular, the functions you're going to see are position function in time, velocity function in time, and the acceleration function in time. These are the big ideas. And then the other words are related to these three issues, these central issues. So these are the big ones. The red boxes are the big ones. Yeah. So let me continue. So since we're doing physics and in particular we're going to use some mathematics and we're going to model motion, and we want this thing to be predictive and very useful and very tidy and tight, we have to make definitions. And in particular, these definitions are going to somewhat be definitions of how to interpret the functions. So what's the physical interpretation of a mathematical statement? For the most part, interpretation is going to be obvious, quite honestly. So interpretation is one aspect of defining these things. Another aspect of clearly defining these things is to define the relationships between them. Okay, so, and I'm going to spend a lot of time on the relationships, because the relationships happen with calculus. And so this is a calculus-based introduction to these ideas here, but also the relationships between the ideas. Okay, so I just realized that really there is another super important word up here that I should list in this language here. And that word is time. And when you think about time, I think there's two ways to think about time. There is on the instant thinking about time. So, but there's also these moments in time. And I really feel like these are different issues, and I'm going to bring them up right now because I'm going to start off uh, talking in below this definitions line about time. So let me put instant versus moments. So the reason, so time obviously is an important issue, and the truth is the time is just going to be kept by an imaginary clock, or quite honestly, maybe a stopwatch is a better sort of thing for you to keep in mind when we're talking about time. So a symbol for an instant in time is going to be t. So t you could treat like a variable, sort of like x typically is the variable name in early math education, in algebra, and even carrying up into calculus. So for us, t is going to be a nice sort of background variable. It's just, and t is being kept track of on a stopwatch or a clock. So you can keep track of instants in time, and you could say like there's an initial instant and a final instant, for example, or instant number 1 and instant number 2. Or sometimes I like to do this. I like to identify a special instant, give it t star. So that's a special instant when some set of events all happens together or something like that. But anyways, these are all just labels. And then moments in time are small time durations. Duration. So it's a little amount of time that occurs. So these are instants in time. And then this is a time duration, or a difference in instants in time. And when I talk about a moment, though, a moment is really a kind of a calculus-y idea. And so I can talk about a small difference in time, or a small delta t. That is, the little d is sort of like the little version of the capital delta. And this little d has a calculus definition, or at least a physics version of it. And it's the limit that delta t heads towards 0 of delta t. So it's not 0. So little dt, this moment in time, has a time duration that's not 0, but it's really, really small. It's a calculus limit, or infinitesimal. So, which means extremely small or ultimately small, infinitesimal time duration. Yeah, and that time duration would happen between two moments in time. You could say it happens between the moment in time t and t plus dt, so that the time duration dt is t plus dt. It's like the first moment or instant in time minus the second instant in time. So the time duration between these two very nearby times is just that small time duration, or moment. So time, of course, it's a physical dimension, and so it gets to have a unit, and the SI unit of time is called the second. Yeah, but you could talk about even instants in time as a certain number of minutes after some starting of a stopwatch or something, or a certain number of hours after the start of a stopwatch, or days, or years, or eons, etc. There's lots of choices of units, but I'm going to, at least in these videos, stick with the SI unit of time duration, honestly, of of the second. So the second is a particular large time duration. So the next thing I'll describe is position. So position is location. Yeah, maybe location is simply the best. So it kind of goes with the idea of a number line. So we could say that this is the position called x equals to 0, often called the origin. Sometimes the origin is given this script O symbol, and you can be on, say, the positive side of the origin. You could be 2 meters from the origin. You could be 1 meter from the 1 meter mark on the right side, etc. So here, but you can also be on the left side or the negative side. So these are all particular positions. And if I had a little object traveling or having different locations at different instants in time, that object could be drawn on this long dimension, this one dimension. So I could say that the object is there at the time t1, and at the time t2 it's over here. Maybe t2 is later than t1, and it took a delta t equal to t2 minus t1 to go from here to there, etc. Maybe at t3 it shows up over here. So the next time we make a measurement of where is the little dot, it's on the other side of the origin at this later time t3, etc. So it looks like there is a position function maybe that is a function of time. So at different instants of time, you could just put it into the function, and the function will evaluate to be the location or position of the object at the instant that you ask. So you get to ask this function, where is the object when I'm interested? Okay, so this is a position function. So let me go and describe what's meant by displacement. So displacement isn't really a location, or it's not a location. Displacement is the difference between two different locations or two different positions. And this displacement is called delta x. So that big capital triangle, delta, just means that it's the difference between two positions. So it could be like written this way, x2 minus x1. Maybe this position here is the x2 position, and this position here is the x1 position. And because we're thinking about position in time, this would be the position at the instant t2, and I'm looking to subtract off the position at the instant t1 to get the displacement of the particle of the dot between these two times, t2 and t1. So displacement really is the difference between two positions. That's what displacement means.